Hello everyone. I'm Kalyani Shashikant Chaudhary, Faculty of Civil Engineering Department from Vishwabharati Academy's College of Engineering, Ahilyanagar. In this lecture, we are studying the engineering mechanics subject, and this subject is for first year engineering. The syllabus of this subject is as per SPPU 2024 pattern. Here, now we are studying the unit 1 of it, that is force system and its resultant. Okay, now we will study what is composition or compounding of force. It is the procedure to find out the single resultant force of a force system. Composition or compounding of a force is the procedure of to find out the single resultant force of a force system. In this diagram, you can see there are two forces. Okay, number one is 2 Newton and number 2 is 4 Newton force is there. Now we find the resultant of this force, that is 4.5 Newton. This procedure to find out the a single force is nothing but the composition or compounding of force. Okay. Now, the methods to find out the resultant. There are two methods. Number one, by using the formula, and number two, with the help of different laws like parallelogram law, triangle law, and polygon law. Now, the second point, resolution of force. It is the procedure of splitting up a single force into a number of components without changing the effect of the same. Means here there are two forces and we find a single force, and in resolution there are number of forces and there is a single force and we split it in a number of components without changing its effect. Okay. Now, the methods of resolution of forces. Number one, orthogonal or perpendicular resolution. Number two, non-perpendicular resolution by using sine rule. Here is the difference between composition of forces and resolution of forces. Composition of force is the procedure to find out a single resultant force of a force system, and there is only one resultant force of a force system. And resolution of forces means it is the procedure of splitting up a single force into a number of components without changing the effect of the same. A force can be resolved into number of components. Okay. Now, how to find out the result? There are two columns. Observe it carefully. Listen carefully. Okay. Now, the resultant formula for two concurrent force system. Okay. There are like this formula. I will explain it one by one. So, observe the diagram and listen carefully what I am saying. First, I will explain the resultant for two concurrent system only. Okay. Here you can see the P and Q force, which forms a force system, and this force system are concurrent force system. Theta is the angle between P and Q. Okay. To find out the resultant, the formula is under root P square plus Q square plus 2PQ cos theta. This is the formula to find out the resultant of two concurrent force system. Okay. Now, this is the resultant. Now we have to find the position of this resultant with respect to P and with respect to Q. According to that, the formula changes. Okay. Now listen. Look at here. This is the concurrent force system, force P and force Q. Resultant, and this is the resultant. This resultant makes angle beta with force P, and this resultant makes angle alpha with force Q. Now we will find the angle with Q, that is alpha. We will find out the value of alpha here. Okay. To find out the value of alpha, the formula is tan alpha is equals to P sin theta divided by Q plus P cos theta. Now understand how this formula become. Okay. First of all, this is the resultant and we have to find out its angle with respect to Q. So here the angle is alpha. So we put alpha here. Tan is the formula. So alpha and tan. It becomes tan alpha. Okay. Now we have to find the position with respect to Q. So in denominator we put Q here. Okay. Then another force is force P. We put P here. Here write down sin theta and here write down cos theta. Like this way, you can easily remember this formula. Okay. Now we will find the angle beta, that is the angle which resultant makes with force P. Okay. So write down tan beta here. Beta just because beta is here. Tan, which is in the formula, is equals to. Now we have to find the angle with respect to P. So write down the P in denominator plus another force QQ sin theta cos theta. Like this way, you can easily understand this formula and remember it. Here again, I will explain it. Resultant for two concurrent force system. The resultant formula is under root P square plus Q square plus 2PQ cos theta. And if we want to find out the position of it, according to the forces, the formula changes. Angle with respect to Q, that is tan alpha is equals to P sin theta divided by Q plus P cos theta. And angle with respect to P, the formula become tan beta is equals to Q sin theta divided by P plus Q cos theta. Okay, this is the formula and overall calculations, angle calculations for two concurrent force system. But sometimes there are more than two forces, no? Like this figure. Okay, look at this figure. Here are only two forces, that is P and Q. But here are number of forces are there, F1, F2, F3. Likewise, forces are there. So how to find out the resultant of this force system and how to find out the resultant angle for this system, we will see here. Okay. Now I think you look this figure and understand it. Okay. Now the formula becomes under root summation of fx square plus summation of fy square. Now the summation of fx means, look at here, summation of fx is equals to algebraic sum of the forces acting along x-axis, means all the forces which are acting along the x-axis, we will write down that forces, do the summation of it and write down here, that is summation of fx then summation of Fy, algebraic sum of forces acting along y-axis. Okay. Then alpha. Alpha is the angle of resultant with denominator axis. Now for alpha angle, look at this, look at here. Uh, with the help of formula, we find the resultant. Okay, we got the resultant magnitude and direction. Now we have to find this resultant, at what angle this resultant will be. For that, the formula is, look at here, angle with x-axis is equals to alpha. So with respect to x-axis, we are finding the position of it. That's why we will put the summation of fx in denominator. So the formula becomes alpha is equals to tan inverse of summation of fx divided by summation of fy. That is, normally the formula is tan alpha is equals to summation of fy divided by summation of fx. But we put tan here in the right side, then it becomes tan inverse. So the formula is alpha is equals to tan inverse of summation of fy divided by summation of fx, and alpha is nothing but the angle of resultant with denominator axis. Okay, so this is the way to find out the resultant for more than two concurrent force system. But just remember this formula and this formula. This formula we will use when there are more than two forces. Okay. Pause the video and understand this again. Read this again carefully. You will easily understand that what is it. Now we will see the parallelogram law. This is the very simple law. Read the statement very carefully. Observe the diagram. You will easily understand that what is it. Okay. It states that if two forces are acting simultaneously on a particle and be represented in magnitude and direction by two adjacent sides of a parallelogram, then the resultant may be represented in magnitude and direction by the diagonal of the parallelogram which passes through their point of intersection. Okay, this law is very simple. Look at here what it is said. There is a concurrent force system. Adjust, okay, force A and force B is there. Okay, force A and force B. Okay, this is the concurrent force system. Now, if we extend this line here and this line here, then it becomes a parallelogram. Okay, now what this law said, if two forces, number one and number two, these forces are the adjacent sides of a parallelogram. Adjacent sides means what? This and this, not this and this. Okay. This and this means this forms a concurrent force system. Okay. And it has magnitude and it has directions also. Okay. Then their resultant will be the diagonal of this parallelogram. Okay. Now look at here. There are two diagonal. Here also, if we draw a line, then we call it as a diagonal. And here also a diagonal. Then which diagonal we will consider as a resultant? That is the main question. And in this law, it is said that the diagonal which passes from the intersection of these two forces means where there are two forces and the resultant passes from a diagonal passes from it, then that diagonal is the resultant of that two forces. Okay, not this diagonal. Okay, this is the very simple and easily, this law can be easily understood by each and everyone. Okay, there is nothing in it. Now the triangle law. This is also a very simple law. Look at the statements. It states that if two forces acting at a point are represented in magnitude and direction by two sides of a triangle taken in order, then their resultant is the third side of the triangle taken in reverse order. Now look at the figure. There are two forces, force P and force Q. Now the direction of force P is like this here. Okay, it is moving anti-clockwise direction. Look at here like that. Okay, so you will understand it easily and in a better way. This is P and this is Q. This is the anti-clockwise rotation of these two forces, and this forms a triangle. There are only two forces. This force is P and this force is Q. Anti-clockwise rotation, so P is here and Q is here. Now, if there is an anti-clockwise rotation, what should be there? That this third side is also anti-clockwise rotation, and the direction of this force is like this, like downward direction. Okay, not here. But the triangle law said if two forces are represented in magnitude and direction by the two sides of a triangle taken in order, this is taken in order, okay, then their resultant is the third side of the triangle taken in reverse order. Okay, so this is the resultant, and this resultant nature is in reverse order. This is the closing side of the triangle. Okay, now as per the rotation, this direction should be like this here, but we have to denote or denote the resultant in triangle law in reverse order. So the direction of the resultant is over here. Okay, simple law, very simple. Now the polygon law. This is same as triangle. In triangle, there are only two forces are given, and the third side is denoted. Third side denotes the resultant in reverse order. And polygon, there are number of sides, and the closing side in reverse order denotes the resultant of it. We will first read the statement so that you can understand it, what I am saying early. Polygon law. It states that if two forces acting at a point are represented in magnitude and direction by the sides of a polygon taken in order, then their resultant is represented in magnitude and direction by the closing side of the polygon taken in reverse order. Okay, observe the figure. Anti-clockwise rotation is there, but this is the resultant. This resultant does not follow the rotation. This direction is opposite to this rotation. Okay, and this is the closing side of polygon also. This is nothing but the polygon law. These three laws are very important, and their statements are also so simple. Remember it in a very simple way. Just you read the statement, understand the figure, remember the figure, you will easily understand what are these laws and what is the difference between them also. Okay. Now the equilibrant. Equilibrant is the single force which, when acting with all other forces, keeps the body at rest or in equilibrium. Means this is the single force which is responsible to make this body at rest condition or in a stable condition. What it is, you will understand now. If this is a force system, this is the resultant of it. Just due to this force system, there is a motion or tilt in the will happen in the body, but this equilibrant force is acting in the opposite direction of the resultant. Just because of that force, the body will be in it in the rest condition or in equilibrium. Okay. The resultant and equilibrium force are equal in magnitude but opposite in direction. We will find or we will study the basic difference between resultant and equilibrium here in tabular format. Resultant is the single force which produces the same effect that as produced by a number of forces when acting together. Resultant is the combined effect of all the forces is represented by a single force. Okay. And the equilibrium is the single force which acting with all the other forces keeps the body at rest or in equilibrium. The magnitude of equilibrium is same as that of resultant. Okay. From that those figure you will understand the basic difference between the resultant and equilibrium. Now, the orthogonal or perpendicular resolution. This is the most important uh, point. From that, or with the help of this, you have to solve many other problems. So, listen carefully, understand it. Okay. Orthogonal or perpendicular resolution. If the force is inclined, first of all, look at the figure, what it is. This is how we have to resolve the forces, and this is up to 90 degree. So we have to call it that orthogonal or perpendicular resolution. This is the coordinate system. We know that this is x-axis, y-axis. Here we put the plus sign, here minus, here plus, here minus. Okay, this is the coordinate system. Now look, this is the force F1, this is F2, this is F3, this is F4, and we resolved it like this. Okay, I hope you understand this figure. Now look at here. If the force is inclined, then we have to resolve it in x as well as y direction. Because of that inclined force, because that inclined force makes an angle x as well makes an angle with x as well as y axis. Okay, understand this statement again. If the force is inclined, then we have to resolve it in x and y direction. Okay, because that inclined force makes an angle with x as well as y axis. Look at here now. If there is an inclined force, then we have to resolve it in x as well as y direction because it makes an angle with x axis and y axis also. Okay. If the force is on x axis, then there is no need to resolve it. This force is, now look at this force. This force is on x axis. Then there is no need to resolve it in both two directions. Okay. Consider its magnitude only, and for its nature or sign convention, observe its direction. We have to only consider its magnitude. Okay. And now, but what is the sign of it? For sign, observe its direction, whether it is here or like this here. According to that, put the sign. Okay. These are the 4 points like this. Now, this is the most important point, that at which axis the angle is given, always take that component as cos theta. Okay. Now look, I read the statement again and I will tell you that what it will exactly happen. at which axis the angle is given, always take that component, as cos theta. Means this is the inclined force. Okay, this F2 is the inclined force in first coordinate. And this F2 makes angle with the x-axis, that is theta 2. With x-axis, it makes the angle theta 2. So while resolving the forces, we must take the x component as cos theta. Means first we have to write down the magnitude of force, then cos, then theta value. Here theta value is theta 2. So we write it as a theta 2 here. Okay. And the other component is sine component, that is F2 sine theta 2. Okay. Now look at this force, F3 force. F3 force is also inclined force. But now look, this theta 3 is with the y-axis. Okay. This theta 3 is with the y-axis. So the vertical component, we keep it as we have to take F3 cos theta 3. Here we take cos in vertical direction, not in horizontal. Doesn't matter vertical, horizontal. Just matter is what? At which axis it makes an angle. Now here, at y-axis it makes an angle theta 3. So we take the y component as cos theta and the horizontal x component as sin theta. Okay. Now here also theta 4 mixed with the vertical component. So the vertical component here is the cos component, cos theta, and horizontal is the sin theta. That is F4 cos theta 4 and F4 sin theta 4. Okay. This is the simple and best solution of it. Now look at here also. Read the point. When the forces are acting towards the origin, then transfer them away from the origin and then resolve it. When the forces are acting towards the origin, then transfer them away from the origin, then resolve it. Now understand. This is the coordinate system. This force is acting towards the origin. Okay, here. So we have to transfer it away from the origin, like this. Away from the origin. Okay. And then we have to resolve it. Okay. If I extend this line here, we know that theta, here angle is 30 degree. So here angle is 30 degrees. So its opposite angle is also equals to this value. So 30 degree is here. Okay. This makes the 30 degree with the horizontal component. So we are taking Q cos 30 as a horizontal component and Q sin 30 as a vertical component. Okay. Now it is towards the origin. Take this P force away from the origin and resolve it. If in a force system, in a general force system, some forces are like this, then we have to transfer it away from the origin and then resolve it. And resolution is same as before. At which axis the angle makes, take that component as a cos theta and the other component as a sin theta. Now, sine law or sine rule or sine formula. We need it for the non-perpendicular resolution of a force system. Okay. Now understand this sine law very carefully. With the help of this sine law, you can find the missing sides and missing angles. And this formula is also so simple. Okay. Now, first of all, we will have a look on some basic points of it, like law of sines defines the ratio of sides of a triangle and their respective sine angles are equivalent to each other. The sine rule is the relationship between the size of an angle in a triangle and the opposite side. Now, this statement is most important. Understand. The sine rule is the relationship between the size of an angle in a triangle, okay, and the opposite side. The size of an angle means what? Its magnitude means its amount or its value. If we consider that ABC is ABC is the point and also the value of this angle. Okay, then it is the relationship between this angle and its opposite sides means the front side of it. Okay, the law of sines is used to find the unknown angle or the sides of an oblique triangle. Okay, as I said before, the sine rule is important to find the missing side and missing angles. Here is also the statement said same thing. The law of sine is used to find the unknown angle or the sides of an oblique triangle. Now, what is oblique triangle? The oblique triangle is the triangle which is not a right angle triangle. Now here, this is the most important slide. From that, you will understand how to find out the missing angle. Okay. First of all, we will read this statement that even though there are three relationships in a triangle between the three angles and their opposite sides, we only need to use two of them for the sine rule. Means what? There are three relations, but to find any value, we have to use only two relations of it. Okay, means these two or these two or this and these two as per the need. Okay, now this formula is for missing angles. Now understand how this formula becomes or how these statements come. Okay, first of all, understand this figure. This is an oblique triangle. A, B, C are the points and also act as an angle of A here, C here, and B here. Okay, and small a, B, C denotes the side of it. Okay, A side is between B and C, B is between A and C is between A and B. These are the sides of it. For our better understanding, we put the capital A here and its opposite side we denote it as a small a. So the formula become like this. And this is also same. A, B, C are the points and also the angle between them. A, B, C are the sides of it. Small a, B, C are the sides of it. Capital A, B, C are the angles of it. Okay. And we use in every day, where sine. Okay. Now the formula, how the formula becomes. Okay. Missing angle. Sine, if we have to find out the angle A, then the formula is sine A divided by A. The angle A of A and its opposite side. Sine B divided by B. Angle divided by its opposite side. Sine C divided by C. Angle and its opposite side. Now the missing side. Here also for that there are three relationships, but we have to use only two of it. Okay, the formula is simple, just we have to do inverse of it. A is in denominator here, put A is in numerator here, and sin A is in denominator. Like side divided by its opposite angle, side divided by its opposite angle, side divided by its opposite angle, and whenever you put the value of angle there in front of them, we have to use the sign. Like this, we can find the missing sides of an oblique triangle with the help of sine law. Okay. Now, students, understand or listen carefully that here I am going to or I am trying to teach you the engineering mechanics subject in a very easy language and in simple way. These notes you can use it or you can read it. These are the so simple notes. Take notes of it, make a book, make a notebook, and write down all the definitions in your notebook there. If there are some figures, then try to draw it with your own, okay, and read these uh, definitions and all the formulas again and again. Again and again. Okay. Now here, look at here. This lecture is much more important. Before this lecture, I took uh, I took one lecture on engineering mechanics introduction. First of all, if you don't understand this, first of all, try to watch that lecture also, and after that lecture, watch this lecture so that you will get a link of everything and you will understand that what is engineering mechanics, what is composition, what is resultant, what is equilibrium force, and all these things. Now, and with the help of this formula, you have to find out the solution for various numericals. So listen, uh, so watch that lecture also, and in that lecture also I make very simple and very short notes there. Try to use them for your study. Okay, write down all the whatever the PPTs I share here. Write down in your notebook all the forces. Okay, here what now I will brief that what portion we will cover. We covered here, like we study that what is composition and what is resolution. Listen carefully. There are composition. If we say composition and resolution, but in composition there are, if we can find the resultant by two methods, that by using formula and with the help of different law. So in composition title only, we have to or we learned that parallelogram law, triangle law, and polygon law, and the resultant approach for two concurrent force system, and for more than two concurrent force system. This portion is comes under the composition and compounding of force. And when we study the resolution of forces, in resolution of forces there are two methods, that orthogonal or perpendicular resolution and non-perpendicular resolution. For that, we here look at here. This is the orthogonal resolution. Okay. So means perpendicular resolution and non-perpendicular resolution. For that we study the sine rule. So there are so many things in this lecture we covered. If you don't understand it in one shot, try to read the statements again, watch the video again, pause each and everything, write down, make the note of it, so you will understand what it is. Again, I am saying that I try to teach you the engineering mechanics subject in a simple and short way so that you can easily solve all the problems or write down all the concepts in your examination. So please your please make a separate notebook for it. Write down all the concepts and all the definitions there. Okay. Thank you so much.